Okay, so today we're going to be doing topic 6.2, and we're going to be reviewing chain rule, product rule, and quotient rule. Okay, so the way the IB booklet has the derivative of x to the n power is like this. So they have that notation I was talking about. Over here. N, x, and minus 1. Alright, and the way this is basically you have, let me write it down over here. You have the x to the n, and what you do essentially is you take this n over here and you swoop it to the left of the coefficient. So now we have nx, and then we have the n over here. But once you bring the n to the left side of the coefficient, you have to subtract 1 from the exponent. So then you get nx to the power of n minus 1, which is how you get this. All right. Now, since we know how to do like a simple differentiation, we can now move on to chain rule. So chain rule essentially is basically taking the derivative of the outside function and leaving the inside alone, and then multiplying that by the derivative of the inside function. So you have, I'll just mark it like this, derivative of the outside, and then you leave inside, and then you have just the derivative of the inside. Okay, so basically you multiply that, and then you get the chain rule answer for, not the chain rule answer, you use chain rule to get the derivative. So also the way that this is notated in the IB formula packet, you have derivative marked as this, dy over dx, and basically it's notated like this. But basically what this is saying right here is you find the derivative of the outside function, leaving the inside function inside there still, and then you multiply that by the derivative of the inside. Now let's work through an example. So our example is going to be y equals 3, I'll show you what I mean by inside function, 3x plus 1 to the 7th power, right? So this 7 right here, this exponent, this is going to be our outside function, and inside here, this is going to be our inside function, because this is closed off, and this is, adding on to this function itself. So what's always good to do is to notate which is your inside, which is your outside. So we'll just mark and know that this 7 is, we'll say OF for outside, that's not an F, OF for outside function, and then we'll say 3x plus 1 is equal to the inside function. I'll do IF. So now, like I was saying, derivative of the outside function leaving the inside. So just like we were doing with the basic derivative of x to the n power, we'll take the derivative of this and we'll do the swoop and bring, this is the n, swoop it to the front and then subtract 1. So leaving the inside by itself. So we have now 7, 3x, this isn't writing, 3x plus 1, and since it's 7 minus 1, we get 6, and that's the first part. Then we multiply that by the derivative of the inside, right? And basically 3x plus 1, 1, since 1 is just on a graph, just a line 1, there would be no tangent, so the tangent 0. So that you don't have to put anything for that. But 3x, it has the exponent of 1. Bring that over, you have 3, and subtract 1 from this one, you get 0. So then x to the 0 power is 1. So then you just get 3. So then you have 7 times the quantity of 3x plus 1, and that's to the 6th power. And you multiply that by 3, is what we have as our derivative. And when you simplify that, you get 21 times the quantity of 3x, we only multiply this, 3x plus 1 to the 6th power. Alright, so next up, right after the chain rule, we have the product rule. And yeah, so basically in the IB formula packet, basically for finding the derivative using the product rule, we have this this little formula right here saying, I'll explain what these variables mean right after I go through the rest of it. But basically u, it's u times the derivative of v plus v times the derivative of u. And then obviously we're gonna keep this over here because this is like the base differentiation and the one that's gonna be applied in the chain rule, product rule, and the quotient rule, because that's how you differentiate, you know, the basic x to the power of n. So basically what this means right here is you have two functions multiplying each other, right? So basically in order to find the derivative of that, you have to have I'm gonna write it underneath here and write the letters like what I mean in words over here. You have u times the derivative of v, and then you have plus, so this is multiplied together in like one big group, plus v this time times the derivative of that, I'm sorry, right, should be right before, no, yeah, the derivative of u. Now in letters, this would be the first function. So you would have, let me write number for it. First function. And then you have, I'm gonna write d for derivative, d of the second function. Sorry, it's squeezed in over there. And then you have the normal of the second function. Second, just the normal equation, normal function. And then you have over here the derivative of that first function. So d of first function. Okay, so it always makes things easier instead of looking at this, because this, I know it confused me. This is kind of confusing, but if you have it broken down into different variables and you have it, you know, worded out and you know what you're going to do, it makes it a lot easier. So let's work on an example. We have y is equal to, and then these are when the two functions come in. You'll see what I'm talking about. X squared plus 1 times another function. You have x cubed plus x plus 5. Now over here, this is what I mean by u and v. This equation right, this function right here is u, and this function right here is v. So all we have to do now is just plug in the different things into the formula. So first we have u, just normal u. So now we have x squared plus 1, simple. Then the next step is to multiply that times the derivative of the second function. So over here, since we have the xn, we have to swoop over the n, then subtract 1 from the exponent. This is easy. We have x to the third power, swoop over the 3. We have 3x, then subtract 1 to the second power. And then since there's an invisible 1 right here, visible 1 right here, 1 times 1, just 1, 1 minus 0, 0, x to the 0 power 1. So then we just have 1 over here. And then 5 on the graph, if you just have 5, it's just a horizontal line, so you can't have a tangent. So then this would be that. So then this is together. And then you want to add that to just the normal second function. So over here it's just this. X to the third power plus x plus 5. And then again, you want to multiply that to the derivative, but this time it's the derivative of the first function. Also really easy, use the same, the basic formula, Swoop over the 2, we have 2x to the first power, which is basically just it itself. And then since y equals 1 is just a horizontal line, there's no tangent. So then it's plus 2x. So this essentially would be the derivative right here. So let me notate it like this. Sorry, I put that inside this. This essentially would be the derivative right here. Okay, so lastly we have the quotient rule. And the way it's, the formula that's in the ID formula packet for the quotient rule is the derivative equals v times the derivative of u minus u times the derivative of v, and then that whole thing divided by v squared. Now u is the numerator function and v is the denominator function. So basically, to write that to make it easier and sort of have variables for each of these things, we just put, we have, v the denominator, and times u, the derivative of u, and then, let me write this down so you can tell it's a u, and then minus u times the derivative of v. And then again, let me make this. And then that whole thing's divided by v squared. Okay. Then for an example, you can take a look at this. f of x is equal to x squared plus 1 over 3x minus 2. Okay, so first we have the numerator. We have, now first we'll take the denominator. In the formula we have 3x minus 2. And then we multiply that by the derivative of the numerator. So again, with this original way of differentiating x to the n power, we take the derivative of the numerator. So then swoop this around, we have 2n, or not 2n, 2x, and then we subtract that by u, so we already have x squared plus 1, and then that's multiplying by the derivative of the denominator. So then we have 3, and then that whole thing, let me write this down as well, and that whole thing is divided by v squared, and v is over here. So we have 3x minus 2 squared. So that would be your answer. These 3 problems are your homework, and these are the correct answers.